All right, guys, so I'd like to go through some motion graphs. The first one here is a displacement or position versus time graph. All right, now we'll notice in the question, this is a trip to Lulu's. Okay, it says it's a straight line. All right, which means that positive here is going to be going over to the right. So here's my house. You could read the question. Here's Lulu's. Okay, so this is going from my house to Lulu's, and it says Lulu's is 1 kilometer, so 1,000 meters from my home. Okay, so that's what's happening. So note the x-axis in terms of minutes. So I'm going to write that down here, minutes. We'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, just so there's no confusion later. And the y-axis is in units of 100 meters. So 100, 200, 3, 4, 500, 6, 7, 8, 9, 1,000, right? And then I guess it goes up to about 1,200. All right, there we go. So let's see if we can answer some questions. All right, the first question is, what is my speed as I leave home? All right, so this is a position versus time graph. And the position versus time graph, the slope of a position versus time is equal to your velocity. Now, your instantaneous velocity is the same as your instantaneous speed. The only difference is that velocity, you have to give direction as well. All right, so what we're looking at here is the slope. It says at the beginning, as I leave the house. So what is the slope here? All right, yet now you'll notice that in 3 seconds here, I travel 600 meters. And so what I'm going to do is I'm going to go 600 meters divided by 3 seconds, and I get 200 meters per second. And so that's going to be the speed as I leave home here. That's the answer to the first question, 200 meters per second. All right, what is my speed when t is between 3 and 4? All right, so that's between here and here. Now, you look and you see that the position is not changing. Well, if the position is not changing, what does that mean? It means that I'm at rest. Okay, so my speed there is 0 meters per second. So what might be happening here? Maybe there's a stoplight or a stop sign, and I actually have to sit and wait for a couple of people to pass before I can go, right? But something's causing me to stop, very likely some type of stoplight. All right, how long did it take to get to Lulu's? Well, we know that Lulu's is 1,000 meters away. So we look at 1,000, and where is the 1,000? Oh, there it is. There's my 1,000 meters. 1,000 meters is at 6 minutes. So it took me 6 minutes to get to Lulu's. All right. How long did I spend there? Well, how long was I at that 1,000 meter location? Well, it was from 6 here all the way until 11. And you can see that I spent all of this time at that 1,000 meter mark, meaning I'm likely at Lulu's. All right, so that would be from 6 to 11. That's a total of 5 minutes. All right, what's happening at t equals 12 minutes? All right, so 12 minutes is right here. So let's see what's happening right there. Oh, look at that. My position was going away from home, and now it's going towards home. So what happened there? I changed directions. Maybe I had to do a U-turn or something. Right? But I changed directions. I went from this positive slope. I was going further, right? That's what displacement or position is showing. As I go up, I'm going further from home, and now I'm going closer to home. So what's happening? I'm turning around. Maybe there's a roundabout or some type of U-turn, right? I can't get going the direction that I want to right away, so I got to start going the other direction. All right, awesome. What is my velocity for the last 2 minutes? So that's from 12 here up to 14. and you'll notice that I was at 1200, and now my final displacement is 0. So I'm doing 1200 minus 0. That gives me my displacement for the last 2 minutes. And you'll notice that I'm just going to get 600 meters per minute. All right, so significantly faster on the way home. Maybe I'm on a highway. Maybe I realized I was late for something. Whatever may be happening, 600 meters per, not second, that would be really fast, per minute. All right, how does this compare to my velocity at the beginning, and what might it mean? Well, I'm significantly faster. And the other thing I didn't mention here is that my velocity was negative, right? It was going down. It should be the final position minus the initial position. So I apologize, make a slight mistake here. I should have gone 0. Ooh, that was fancy. Should have gone 0 minus 1200, which would give me a negative 600 meters per minute, right? It should be the final position minus the initial position, like that, to find the change. All right, so significantly faster and opposite direction, right? Because it's negative instead of positive. All right, and the last thing, at what times does acceleration occur? Well, acceleration occurs anytime that now I can use my highlighter. Acceleration occurs anytime that my velocity changes. Well, during a constant slope, that is a constant velocity, so that's not what I'm looking for. I'm looking for this point when the velocity changes. So when it changes from going up to being flat, that's a change in velocity. When it changes from being flat to moving again, right, that is a change in velocity. Right here is a change in velocity. Every time my slope changes, any change in slope or direction is a change in velocity. And so I could say that my velocity changes at 3 seconds, 4 seconds, 6 seconds, 11 seconds, oops, forgot my seconds, 12 seconds, and probably again at 14 seconds if I stop when I get back home again. All right, so each of those time points, there's an instantaneous acceleration that occurs. We can't really put a volume on it because it all of a sudden changes. Okay, we'll look more at that later in a different question. All right, and that's the end of this question. All right, let's go ahead and watch the next video if you want.